An ordinary day. The sun is shining, the streets are calm, people are going about their business. Nothing hints at trouble. But in just a few minutes, everything can change abruptly. The sky will darken and the air will fill with unease. A tornado is one of nature's most powerful phenomena, a mesmerizing yet deadly funnel. Inside the funnel, wind speeds reach up to 500 kilometers per hour, turning anything around into dangerous flying projectiles. It lifts cars into the air, rips roofs off houses, and sweeps away entire neighborhoods, leaving chaos behind. In just a matter of minutes, an entire village can be gone. Only foundations and scatterings of debris remain. In the U.S. alone, more than 1,000 tornadoes are recorded every year, on average several funnels each day of the season. People run, hide in basements, pray, and call loved ones while sirens wail and the wind roars louder and louder. But even today, scientists can't say exactly where and when a tornado will appear. Warnings give only minutes. What is it, really, and why does it form the way it does? Let's sort it out without unnecessary complexity and myths. And why are some regions of the planet true magnets for tornadoes, while others hardly see them at all? Today, we'll go through everything in order. Simple words and clear examples so it's easy for everyone to grasp. Let's start from the very beginning. What a tornado is, what it looks like, and what its power is made of. Block 2. What is a tornado? A tornado is a rotating column of air connecting a thunderstorm cloud to the ground, sometimes hundreds of meters wide. Outwardly, it looks like a funnel, like a long elephant's trunk slowly lowering straight from the sky to the ground. They come in many forms, narrow like a rope or very wide, up to 3 kilometers in diameter, sometimes more. Over water, they're called waterspouts, no less eerie looking and capable of overturning small vessels. In deserts, you can encounter dust devils, the tornado's little brothers, almost harmless but an impressive sight. Scientists classify tornadoes by the EF scale, from EF0 to EF5, based on damage and estimated wind speeds. EF0 is the weakest. It breaks branches, tears off signs and light roofs. Wind speeds up to 135 kilometers per hour. EF3 is already serious. It rips off roofs, collapses walls, overturns trains. Wind speeds up to 330 kilometers per hour. EF5 is the maximum. Only the foundation is left of houses, and winds often exceed 500 kilometers per hour. Absolute devastation. For scale, the largest tornadoes rise so high that they're above the cruising altitude of passenger jets. The average forward speed of a tornado is about 50 kilometers per hour, but some accelerate to 110 kilometers per hour and slip away. It leaves a swath of destruction, sometimes hundreds of kilometers long and hundreds of meters wide. Tornadoes have always existed. The first reliable records date back to the Middle Ages in eyewitness chronicles. Today, specialized scientists and teams hunt them, driving toward the funnel to study it from the inside. But how is this monster born? Let's break down the physics in simple terms. No complex formulas or lofty jargon. Block 3. How a tornado forms. It all starts with the sun. It heats the ground, and the ground transfers heat to the air above it, setting. Warm air is lighter than cold, so it rises, making room for denser, colder masses. At the same time, cold, dry air descends from the north, and warm, moist air flows in from the south. The meeting is inevitable. When the flows meet, the battle begins. Cold, heavy air presses downward and warm, moist air surges upward. The collision gives birth to a powerful thunderstorm cloud, rising upward almost as fast as an express train. The key: at the different altitudes, the wind blows in different directions and at different speeds. Wind shear forms. This makes the air between them rotate. Imagine a horizontal roll spinning like a drum between the flows. The updraft inside the storm picks up the roll and sets it upright, integrating it into the cloud's structure. Now there is rotation inside the cloud. This structure is called a supercell, a true tornado factory. A supercell looks frightening, huge, dark, with visible rotation at its base and a wall of cloud. The rotation accelerates, the pressure at the center drops, and the funnel starts stretching downward toward the surface. As soon as the funnel touches the ground, a tornado is born. From that second, it destroys everything in its path. Why is it so fast? Think of a figure skater. Pulling in their arms, they speed up. The air follows the same principle. Air is drawn into the narrow funnel. Speed rises sharply, and that's where the monstrous destructive force comes from. Now you know how it's born. But why is it so destructive? Let's explain with simple examples. Block 4. Why a tornado is so destructive. A tornado doesn't kill by wind alone. Thousands of debris pieces fly inside the funnel, turning everything into a giant meat grinder. A basic wooden plank at around 400 kilometers per hour easily pierces a brick wall straight through. A car weighing 1.5 tons is to a tornado like an empty tin can for the wind to pick up. Inside the funnel, pressure collapses catastrophically, creating a powerful, almost vacuum-like suction effect. Imagine a giant vacuum cleaner. Instead of dust, it indiscriminately sucks in houses, trees, cars, and even people. When a tornado passes over a house, the outside pressure drops sharply, and the air inside literally blows the walls outward. That's why some houses are left with only the foundation. The walls aren't torn off by wind. They're blown out from inside by pressure. A tornado has, roughly, 3 zones: the edge, frenzied wind; the middle, chaos and debris; the center, an eerie calm. Survivors recall the center of a tornado as a terrifying quiet. Everything is collapsing around, while inside it's almost calm for a moment. Lightning often flashes inside a tornado. Friction of particles and debris generates strong electrical discharges. A powerful tornado releases in just minutes energy comparable to a small atomic bomb. A tornado's color depends on what it ingests. Red, if it's lifted red soil; black, if it's packed with heavy debris. Every year, tornadoes take on average about 70 lives in the U.S. alone. In the worst years, the toll runs into the hundreds. The deadliest tornado in history, the Tri-State, 1925, passed through 3 U.S. states, taking nearly 700 lives. And here's the big question: why the U.S. in particular? Why do tornadoes happen there more often than almost anywhere else on the planet? Block 5. Why the U.S. is the tornado capital. Tornadoes occur all over the world, in Europe, Australia, Russia, Bangladesh, and dozens of other regions. But about 75% of all tornadoes on the planet occur in one region, the central United States. This area is called Tornado Alley. Texas, Oklahoma, Kansas, Nebraska, South Dakota, and others. The first reason is the terrain. There are almost no mountains here, just a flat plain stretching for thousands of kilometers. Cold Arctic air from Canada slides south unhindered, and there's almost nothing to hold it back. From the south, the warm Gulf of Mexico feeds the continent with moist, heated air, pushing it far to the north. These flows meet right over the center of the country, creating ideal conditions for powerful supercells to form. The Rocky Mountains to the west enhance the contrasts. They redirect and twist the flows, setting up the needed wind shear. It's almost a perfect recipe: cold air aloft, warm air below, flat land, and a mountain barrier to the side. The result is impressive: 1,200 tornadoes every year. That is, on average, more than 3 funnels form daily. The peak season falls in April, May, and June. In spring, the contrast of air masses is especially sharp and produces violent storms. Residents of Tornado Alley live with the risk all their lives. Almost every house has a basement, not a luxury, but a necessity. Towns across the alley have sirens. When they howl, people have only minutes to take cover. By the way, Bangladesh is second in number of tornadoes, but there they're extremely deadly due to high population density. But there are those who don't run. They drive straight toward the tornado. Who are these daredevils and why do they risk their lives? Block 6. Tornado Hunters and the Finale. Storm chasers are scientists, photographers, and weather fans. Their goal is to get as close to the tornado as possible. Some head out in armored vehicles. The Tornado Intercept Vehicle, TIV, weighing 7 tons with anchors that pin it to the ground. Their vehicles carry radars, pressure sensors, cameras, and laptops. This data later truly saves millions of lives. They park a few hundred meters from the funnel. Outside is an infernal roar, and inside the cab, focused silence and work. They throw small probes under the funnel. Those transmit pressure, temperature, and wind speed in real time. These data help us understand how a tornado is born and where it's heading. Every outing is an important contribution to science. Thanks to their work, today a tornado warning arrives 13 to 15 minutes in advance. In the 1950s, there was nothing like that. That's why tornado mortality has dropped multiple times over recent decades. Science and alerts literally save lives. Today, emergency alerts arrive right on your phone, giving people time to make it to shelter. The best protection from a tornado is an underground shelter, a basement, bunker, or any below-ground room without windows. One absolute taboo: don't hide under a bridge. It's a deadly trap where the wind speeds up and sweeps everything away. Scientists debate whether the frequency or strength of tornadoes will increase with climate change. There's no definitive answer yet. A tornado is one of the most beautiful and at the same time dangerous natural phenomena, and that's precisely its pull. Today, is born, why it wipes out everything in its path, and why people devote themselves to studying it. If you found this interesting, subscribe to our channel and stay tuned for new episodes. See you soon.